Welcome to Cookie's Maths and Science Hub. Today, we're exploring the concept of momentum. Momentum is something we use as a measure of the motion of an object and its tendency to keep moving. It combines both the object's mass and its velocity and gives an indication of how difficult it is to stop the object or change its direction. In everyday terms, using a real-life example, a heavy truck moving at a high speed has more momentum than a small bicycle at a slow speed, and it would require more force to bring the truck to a stop or change its course due to a higher momentum. You've probably heard the term momentum before, and it is exactly as it sounds. It's simply the tendency to keep moving of an object. We measure it as P. So P is the letter we use for momentum, lowercase p, and it equals the mass multiplied by the velocity of the object. That means if an object isn't moving, it has no momentum. We can also use momentum to find the force acting on an object over a set period of time. So the net force is equal to the change in momentum over the change in time. Let's have a look at using these formulas now for some basic problems. So a 5 kilogram object is traveling at 2 meters per second, whilst a 10 kilogram object is traveling at 1.5 meters per second. And we're asked to show which has the greater momentum. All this is simply plugging the numbers into our formula. So P, our momentum, is equal to mass times velocity. So our momentum is equal to 5 times 2, which is equal to 10 kilograms meters per second. And for our second object, it's equal to 10 times 1.5, which is equal to 15 kilograms meters per second. You'll see the heavier object, even though it was traveling slightly slower, still has greater momentum. Our second question continues with these same objects. If it takes 10 seconds to bring both objects to a stop, what force is required to stop each object? For our first object, remembering that F net is equal to change in momentum over change in time. If an object's coming to a stop, when it's stopped, it's going to have zero momentum, which means its change in momentum is its total momentum, because it's going to lose all that momentum as it comes to a stop. So in this case, for our first object, our change in momentum is going to be 10. So it's going to be 10 divided by 10, which is just going to give us 1 Newton of net force. For our second object, it's going to be 15 divided by 10, which is going to give us 1.5 Newtons of net force. Again, it requires more force to stop the object with more momentum. An important factor to consider with momentum is the conservation of momentum in a system. When there is an absence of external forces, the total momentum of said system remains constant. If two objects collide within the system, their combined momentum before the collision will equal their combined momentum after the collision. So effectively, our P initial, or our momentum initially, will equal our momentum final within the system. What this means is mv initially is going to equal mf at the end. Now, for having two different objects, what that means is even if one hits and slows down, or the other hits and speeds up, whatever that means, we can write it out as m1 v1 plus m2 v2 is going to equal the same with any changes present. Now, it's important to remember in this case that momentum is a vector quantity, meaning it has both magnitude and direction. It's important to consider the direction, as that can often change the momentum of the objects if they go off in a different direction. In the example we're about to cover, we're only dealing with a one-dimensional problem. As we get further into momentum as a concept, we might cover two-dimensional problems in a later video. Our objects from before, a 5 kilogram object traveling 2 meters per second east and a 10 kilogram object traveling 1.5 meters per second west, collide and combine into a single object. And we're asked to find the final velocity. You'll notice this time I've included directions, as this will be important for the question. So writing out our formula, we have m1 v1 plus m2 v2 equals our final of the same. Now in this case, we're actually going to simplify that formula down because our two objects are combining into a single object. So all we have at the end is mf vf. We don't have those two different objects going off in different directions. Substituting our known values in, we have 5 times 2, subtract 10 times 1.5. Now that subtraction is there because we're setting east as our positive direction. That means that 1.5 west is going to be negative 1.5 west. Now you can put it next to the 1.5, or you can just bring it into the equation, making it a subtraction rather than an addition. That is going to all equal 15v, or 15 times our final velocity. What this is from is the fact that when the objects are combined, their masses have combined. So 10 plus 5 gives us 15. So solving the left-hand side, we end with -5 equals 15v. Then just dividing both sides by 15 gives us v is equal to -0.33 meters per second east, making sure you include the direction as momentum is a vector quantity. You can also write that out as v is equal to 0.33 meters per second west, getting rid of the negative and just writing out the specific direction. Thanks for watching. Hopefully now you have a good idea what momentum is and how to apply it to a few different situations. Be sure to leave a like and subscribe to the channel for all future maths and science videos. Hope to see you back again soon.